integrate by u substitution. Okay, sometimes it's going to be an integration. You're looking at it, you're going to be like, I have no idea. But really, I always say it's not that hard, but you guys still think it's hard. So it's simpler than you think. Okay, so set the appropriate expression equal to u. Okay, hence the title u substitution. Okay? We're going to substitute a u in for our expression. All right. Then we are going to find du, which is the same thing as u prime, or the derivative. It should say of u, not derivative or u. The derivative of u. Okay. So I take my expression. Okay, and I substitute a u in for it. Whatever that expression was that I put in a u for, I'm going to take the derivative of it. Okay? Then I'm going to solve it for dx. We're going to substitute both u and du into the integral and solve it with u. Okay? We're going to solve it with u. Don't forget to put the original expression back in for u. Or, because step 4, the last step, you kind of really do it 2 ways when you solve it. And some people either prefer one way or the other. It's weird. Or, if you do not put the u, the original expression back in for u, you know the upper and lower bounds when we take an integral? It's to the top and bottom of that little s thing. We would have to do a u shortcut with those as well. Okay, and I'll explain that in a second. All right? Ready? Here we go. Let's perform a u substitution. So this might be an issue. What's one way you could do this without u substitution? That would make it easy for you. Initially, making you do a lot of work. Any suggestions? If I got stuck in a problem like this, and I would actually expand that out and do it 5 times FOIL it. So I have a big, long polynomial. And then you're just the integration of each term in that polynomial, right? But that's a lot of work. That's a lot of work. So we're going to use u substitution here. I'm going to take an expression. Now, this might be difficult to integrate, but let's say right? Let's say that I'm going to make x plus 4 u. So I am now going to integrate. This is u now, isn't it? U to the thing. But Tommy, what did it say I had to do? I got to take a derivative. Because now this is a u, and it's not an x anymore. Remember, this is just whatever variable we have here. It is a u now. I can't put this. I got to put du. Which means, how do I get du? Well, if I take the derivative of this, I told you when we do it, it becomes a lot more clear. Now, what's the derivative of this? It's 1, but it's 1 dx. Right, whenever you take the derivative of x, it's dx, right? It's, like y, it's dy. Same thing. So, whenever there's a dx, I'm going to substitute in a du. There you go. Now, how do I integrate that right there? Just think of u as an x. It's just a variable to the thing. What were our rules for integration? It was the reverse math in the reverse order of taking a derivative of it, right? Okay, if I was taking the derivative of this, I multiply by 3 first, then I subtract 1 next, right? So I gotta add 1 first, then divide by it, don't I, right? So I add 1, then divide that, right? So it is u to the 6th all over 6. That can't be our answer, because what was u? What do we substitute in for u? X plus 4. So keeping in mind that u is actually x plus 4, what do you think my answer is? Knowing that u is x plus 4, what's There you go. I just plug it back in. Thank you very much. You guys always expect this complicated one, and it's not crazy, okay? Now look it. Let's check this. If I had to take the derivative of this, okay? If I had to take the derivative of this, and I should end up with u, excuse me, yeah, u, x plus 4 to the fifth. This is what I should end up with if I take the derivative of this thing right here, correct? So, I'm going to take the derivative of this, and I'm going to break it up so it's a little bit easier. I'm going to say this is 1/6 times, I don't know why I'm stuck on u now, x plus 4 to the 6th, right? So I can take this out and just take the derivative of this and put the constant back in, can I? Yes. I bring the exponent down. Subtract 1 from the exponent times the derivative of the inside, which is just 1, isn't it? Then I have my 1/6 out front, don't I? These cancel. This means nothing. It works. Example 2. Example 2. What do you think I should put in for u? What do you think I should put u in for?
3x plus 4.
Yeah, 3x plus 4. How come? If I make u equal to 3x plus 4, okay? So write for this here about the integration of the cosine of u, okay? Now, I know how to integrate the cosine of u. What is the integration of the cosine of u? Sine, right. So that means, what do I have that if I take the derivative of it will give me cosine? Sine. Okay, well, let's just keep that in the back of our minds right now. But remember, this has got to be converted as well, doesn't it? What is the derivative? du would equal 3 dx. Now, here's... I've got to put in for dx, not for 3 dx. So I need to get that dx alone, because I only want to substitute in for this. So how do I get this alone? I divide by 3, so I write it like this: 1/3 du equals dx. See what I'm saying? So that is going here. Is there any confusion there? And what can I do with constants just like I can with derivatives? Put them out front and wait till the end. So this 1/3, I'm literally 1/3 of the integration cosine of u du. You just told me that the cosine of u was, or excuse me, the integration of the cosine of u was sine. So this is 1/3 times the sine of u. Right? Well, what was u?
3x plus 4.
U was 3x plus 4, wasn't it? Time to put this bad boy back in. So we've got 1/3 times the sine of 3x plus 4. That's my answer right there. And if I wanted to check that, and see if I get the cosine of 3x plus 4 if I take the derivative of it, the derivative of sine is cosine. So it's cosine 3x plus 4 times the derivative of the inside, which is just 3, times my constant, my 3 and my 1/3 cancel. That's why I get it. Okay? Good. Example 3. Where is the u going in for? Where is it going into?
1 over 1/6.
What? What's happening?
That's 20. That's 20.
So you're gonna say u equals what? Wait, say what?
1 over 1.
Yeah, I'm gonna go that way. That one, no. Here's why. You don't want to put it in for the whole expression. Otherwise, I would have made u equal to the cosine of 3x plus 4. You just want to put it somewhere where you can still take the integration of it. So if I just put it in for 1 minus 2x, all right, And now I've got the integration of 1 over u. Okay? Isn't that the same thing as saying the integration of u to the negative 1? That becomes a lot easier. Okay? That becomes a lot easier. Now, that's my u. What about my du? Okay. Negative 2, don't forget dx, because I need to substitute in for dx, which means dx. If I divide both sides by negative 2, if I divide this by negative 2, divide this by negative 2, 1 over negative 2 du equals dx. This is what's going in for dx, times negative 1/2 du. And my constant can go out front, can't it? Now it is a million times easier to do. So, what do I do at this point? What do we get? All right. This creates a problem for us, doesn't it? Because if I add 1, then divide by that, that is undefined. It's an issue. So guess what? If I would have made that a negative 2 or negative 3, I'd do it that way. When it's a negative 1, I can't, can I? But what do I know that if I take the derivative of it, it's 1 over something? Anyone remember? No. It's natural log. If I have the natural log of x, the derivative is 1 over x. Okay, times whatever x prime it. You know, if that's like 2x or something, whatever. So I know that ln of u would give me this if I take the derivative of it. Therefore, if I have this and I go backward, that will go back to ln of u. Okay, you guys are looking at me kind of crazy still. I know we just came back from break, and that's what I'm, you know. The derivative of the ln of x is 1 over x. Therefore, the integration, which means goes backward from here, okay, this is derivative. So therefore, if I integrate this, I'll be okay, children. If I integrate that, it's just going backwards, right? So, what is the integration of 1 over u? The ln of u times my negative 1/2 out front. And what was u? 1 minus 2x, right? So we have negative 1 times the ln of 1 minus 2x. All right? Now, because this is calculus, I suppose that would be okay to leave it like that. There's multiple choice. I hope you can realize that when I multiply those together, I have negative the ln of 1 minus 2x over 2. I just combine. Okay? I just combine. So, it pays off 90% of the time when you have a fraction to just make that exponent a negative exponent when it's 1 over something. Unless it's 1. Because I'm going to just make it ln of u. Otherwise, it's something. Okay? Okay, example 4 is slightly different. New twist. It has bounds now. Okay? Now, when I was talking about integration by u substitution, that fourth step said, don't forget to plug the expression back in for u, or you have to convert your bounds. All right? And I'll explain that with this problem right here. Okay? We're going to start this the same way we've done everything else. We'll worry about the bounds afterward. Okay? So, what am I going to set u equal to? 9 plus x, which means what's du?
Or, yeah.
1 dx, which means it's just dx, right? So, I'm going to integrate this. Okay? U squared, because this turns into u, and this just turns into du, right? Now, right now these are x's, right? They're x's up here, which means if this is still 3 and this is still 1, this means these are x's, aren't they? Right, so we'll finish this problem off and using this axis, or there's something else you can do that I think might be a little bit easier that a lot of kids tend to want to do. Well, let's finish it this way first. You can see both methods and you choose whichever way you want to do this. All right? How do I integrate u squared? What does that become?
U to the third over 2.
Yes. I add one to the exponent, and then I divide by that expression or exponent. So that becomes u cubed over 3. If I were to take the derivative of that, 3 comes down, and cancel the 3 on the bottom, and there's 2. Because when you take the derivative, you subtract, and you just, this is the opposite. Okay? So, I'm taking this expression from x equals 3 to x equals 1, right? So my bounds. So what is my u? 9 plus x. So I've got from 3 to 1, I should write it on that side, of 9 plus x cubed all over 3. Huh? Yes. Okay, and we've done this already. I throw a 3 in here for my x. I evaluate it, then I subtract throwing a 1 in for my x. So it is 9 plus 3 cubed all over 3. That's what happens when I throw a 3 in there. Subtract, what happens when I throw a 1 in there? 9 plus 1 all over 3. And the 9 plus 1 on top is cubed. Okay, you guys all see what I did? All I did was throw my 3 in for x, evaluate it, and then subtract throwing a 1 in for x. Who's got your calculators? What is 12 cubed? So 144 times 12 and divided by 3. Well, I would say 144, yeah, 3 goes into 12 4 times. 16 carry the 1, 17 carry the 1, 476. I don't know. Oh, dang it, no. 18 carry the 1, 144 times 04. Anyways, I'll try, yeah. All right, so you got what?
576.
Minus, well, 10 cubed.
Yeah.
Add one more 0. 1,000 divided by 3, isn't it? In your calculator, do this. We'll do alpha y equals for your 1,000 over 3, so it gives you a fraction as an answer. Yeah, don't do that at all. I want an exact answer. So do 576 minus alpha y equals 100 divided by 3. And answer, what do we got?
728 over 3.
Is she right?
Yeah.
728 over 3. Okay? 728 over 3. That's one way to do it. I think the other way is simpler math. And let me explain to you why. I had to put my expression back in for u. I had to put this back in order to solve it. But what happens if I could have just solved it like this with the u right there? Wouldn't that be a lot easier? Because now I don't got to cube some expression, 9 plus x, whatever. Watch what happens. If u equals 9 plus x, my upper limit, I'm going to call this ul, x equals 3, right? So therefore it is 9 plus 3. Right? I'm just throwing a 3 in for x in my upper limit. So therefore, my upper limit in terms of u would be 12. What about my lower, I said limit or bound, I should use upper bound. My lower bound, x was 1, wasn't it? So now it's 9 plus 1, which is, so now, if I don't want to substitute my expression back in for here to make them x's, I can substitute these in to make my bounds u's. This will turn to a 12. This will turn to a 10, right? Did we just figure that out? So look what I have now. I have u cubed over 3 from 12 to 10. That seems easier to me. You get 12 cubed over 3 minus 10 cubed over 3. Guess what you get?
78 over 3.
So you can either put back in the x expression for the u, which is the way I always did it in college, or you can just change, once you have this expression here, just change your bounds to u, using your u substitution. Whatever your x values were for the bounds, just plug them there. That's your u value. Does that make sense? There's a lot of talking. What? This looks way too complicated. That's what you guys all say. Relax. The help you seek is literally right in front of your face. No, not me. Irving, not me. It's in the problem. Okay? So what do we got to do? What do you think I'm going to make my u equal to? 1 plus x squared. So what does that make my du? 2x dx. So what do you notice as I substitute in? I have my integration. Okay, it's going to be radical u, right? Now, du goes in for what? So this turned into a u. Where's my du go in for?
dx.
The what dx? 2x dx. Oh my God, 2x dx. That will turn into my du. It is literally right in front of your face. Now, how do I know which one to, how come I don't make my 2x u? Well, if I made u 2x, what's du? 2 dx. I still can't get rid of that 1 plus x squared. You have two expressions there. Forget about the radical, that's going to stay. You have 1 plus x squared and 2x. One of them is the derivative of the other, isn't it? So set u for your primary expression. That way, when you take the du, you'll get the derivative of that in your du. Okay, does that make sense the way I'm trying to explain it? One of them is the derivative of the other. I don't know what I just said. One is the derivative of the other. Okay? Well, if I know 2x is the derivative of 1 plus x squared, then the 2x should go with the du. Because it's a derivative. Okay? And, I mean, what fractional exponent is a square root? Close. Say it again. Close. Yeah, I thought I misheard you. There's one minor detail. It's just 1/2. If it's negative, it would flip and be in the denominator. Now, what do I do with that exponent? I got to integrate it now, right? So I add 1, and then I divide by that, right? So u to the 1/2 plus 1 all over 1/2 plus 1. Which 1/2 plus 1 is 3/2 over 3/2. Right? It's the same thing as saying 2/3 times u to what radical? The square root of u cubed. Top down, bottom out. The top comes down, The bottom pops out. Top down, bottom up. Yeah.
Bottom up.
Now, what was my u? 1 plus x squared was my u. We have it right here. It was 1 plus x squared, so we're just going to put that back in. There's no bounds. I don't got to figure out what it is after that. I have 2/3 times the square root of 1 plus x squared cubed. And if I write that correctly, I'll put this on top of the 2 and the 3 on the bottom. When I combine them. Okay, I'll write 2 times the square root of 1 plus x squared cubed all over 3. Now, did I introduce you to the letter C here yet?
I think so. Right.
We are. Last thing would be this. No, we're good.
No.
Let's leave it like that.